Hello everybody, welcome back to the online course on computer organization and architecture. We are in the module fundamentals of digital computer, and now we are in unit 4. The unit 4 is related to basic elements of processor. So, as usual, now first we are going to talk about the objective of this particular module. We have identified 3 objectives for this particular unit on basic elements of processor. The objective 1, illustrate the components of a processor. So, we are going to see what are the elements we have in a processor, and the level is your in knowledge level. So, in this particular unit we are going to discuss everything in knowledge level only. So, we are going to just give idea about it, but in subsequent module these things can be covered in higher level, maybe in the design level and synthesis level. Objective 2, describe the different categories of registers. This is in comprehension level. What is register we are going to see, and what are the different categories that we have, we are going to look into it. Objective 3, explain the tasks performed in an instruction cycle. So, already in our earlier unit I have talked about the instruction cycle, how to execute an instruction. Now, we are going to see what are the different tasks or sub tasks that we are going to perform in an instruction cycle. So, this is in analysis level. That means, once you see an example of an instruction, then at least you will be able to analyze what are the tasks that will be performed by this particular instruction, and finally, what is the effect that we are going to have after executing this particular instruction. So, we have seen the top level view of your computer structure. So, in this particular case we are saying that we are having 4 basic elements: CPU, IO, memory, and they are connected with system bus. So, this is the computer that we can see, components of a computer. Now, in this particular unit we are going to talk about the processor, CPU, central processor unit. Now, if you look at it, then you can bubble up this particular bubble of CPU, and we are going to see that basically it is having 3 major components. One is your arithmetic and logic unit, then we are having the registers, which are nothing but the storage unit, and along with the control unit. Control unit is having the responsibility to synchronize the operation inside the processor, and all those components are connected through this internal CPU interconnection, because sometimes or many a time you have to transfer information from one component to the other component, like the transferring the information from registers to the ALU, or maybe the result from ALU to the registers. So, for that we need to have the interconnection. So, we are having the internal CPU interconnection. No, this is the internal structure. It is very generic one. In most of the cases you are going to see this is the internal structure of a processor, but it may vary from processor to processor, but in general we are going to have those components. So, just see what are the basic components that we are having. We are talking about the registers. These registers are nothing but the storage element. So, here we can store our information. Another component we are having called ALU, arithmetic and logic unit. So, this is the main processing element inside the processor. Here we can perform some operation, like in ALU. Inside that we are having a component called which have arithmetic and logic operation. So, some of the arithmetic operation we can perform like addition, subtraction, multiplication, division, etc. Along with that we are having the provision to perform some operation, Boolean operation like AND, OR, exclusive OR, etc. So, these are the basic operations that we can perform. Along with that, sometimes we have some other functionalities also. One is known as your complementer. Basically, it is going to complement a given number. Another one, we are having a shifter. Already we have talked about the shift registers. That means, sometimes we have to shift the contents of a register, either it is your left shift or right shift. So, for that also we are having this particular shifter, and along with that we are having status flag. We are going to see or going to elaborate what is those particular status flag, but already we have discussed some of the issues related to those particular status flag when we talked about the arithmetic operation inside the ALU. So, we are going to see what is the effect of those particular components. Along with that, now say we are having registers and arithmetic and logic unit. Now, we are having a interconnection of this particular component. So, here we are having a interconnection network, which is basically bus. We will see what is bus now. So, basically it is a connecting wire. So, from these registers we can place the information in this particular internal connecting wire bus. From that it will go to the ALU. ALU will perform the operation and result will be transferred to again through bus to the registers if we want to store the result. Now, we have to now perform this operation in a systematic way. Just so that if I want to add two numbers A plus B, then what we are going to do? First we will transfer A from this register to the input of the ALU, then we will transfer B from the register to the ALU, then I am going to perform the addition operation. Whatever result we are getting after performing the addition operation, we are going to transfer it to the registers. So, for that we need appropriate control signal. So, this control unit is having the responsibility to generate this particular control signal. So, these are the control lines connected to different component. Now, what is the control signal? So, first I am going to say that transfer the A to ALU. Now, we are going to select the register A. Inside that ALU we are having several registers in register bank. So, control unit will generate appropriate signal to select this particular register A. Then we will transfer the information to the input of this particular ALU, one of the input of this particular ALU. Then control unit is going to generate the next signals, so that it is going to select the register B, and after selecting the register B, we will transfer the information to the ALU again. Now, after getting both the information A and B inside ALU, now what is the responsibility of the control unit? To generate the signal to trigger the addition operation inside this particular ALU, because we are having several operations inside ALU, and already we have discussed it, already explained how we are going to select a particular processing element. So, control unit is going to generate the signals, so that it is going to trigger that particular addition module of this ALU, and finally, it is going to get us the result. So, once we are getting the result, then what we are going to do? We are going to transfer it to some of the registers. So, again control unit is going to generate the signals. So, the responsibility of the control unit to generate the appropriate control signal at appropriate point of time, and these control signals are given through this particular control path or control bus, and through this data bus we are transferring the data from register to ALU or from ALU to registers. Okay. So, these are the internal structure of a processor. In most of the processor we are having those components, but the placement of the components may vary from design to design. Now, what is the first component that we are going to talk about? It is the register. What is registers? These are nothing but some storage space. So, CPU must have some temporary working space, and which are known as your registers. So, first we are going to take the information and put it into this particular registers. So, after that, once we have the information inside the processor, that now processor can carry out the work according to our requirement. So, the number of functions vary between processor design. So, what are the number of registers that we may have inside a processor? What are the function of those particular registers? It depends on design of the processor. So, it varies from design to design. So, this is one of the major decision in processor design, and we have to see how many registers we are going to keep and what are the purpose of these particular registers. And secondly, we can consider this as a top level of memory hierarchy. What is a memory? These are storage element. So, I can store information. So, this is top level. We are saying that this is inside the processor itself. Some processor is going to work with the information available on these particular registers. Now, where from we are going to get that information into those particular registers? If you see the working principle, von Neumann stored program principle. So, that means we must have storage element, which is the memory module. So, that will be connected to the processor. So, this is the next level of storage in the memory hierarchy. So, in the memory hierarchy, top level we are having a register where we can store our information, but where from we are going to get information to that particular memory or registers? It is from the main memory. So, main memory is the next level. So, we can have a hierarchy of memory, and in this particular course we are going to see what are the defined level of memory that we have in a computer. So, just I am mentioning that it is a top level of memory hierarchy. So, registers are nothing but a temporary storage unit which are placed inside the processor itself, and processor is going to work with the information available in the register. So, what are those registers. So, registers can be categorized into different parts. One is known as your user visible registers. Why you are saying this is user visibles? Because these are the architectural issues, and we know that there are some registers inside the processor, and while writing our program we can use those particular registers. So, that is why you are saying this is the user visible registers, and these can be used by a programmer while writing his program. Maybe when I am going to talk about the writing a program, we will see in what level basically we are mentioning about it. So, these are the registers an user or a programmer can use. Again, in this user level registers can be categorized into 4 different categories. One is your general purpose, data registers, address register and condition codes. So, general purpose register, it can be used for any purposes. You can keep or you can store any information or any kind of information inside the general purpose registers. But if you are going to say it is a data register, then what will happen? We can store only data that we are going to work on. So, data register can keep data only. When we talk about the address register, basically this is going to keep the information about the address. Now, what is an address? So, you already have mentioned that our computer works on von Neumann stored program principle. So, for that we are having a storage unit which is known as your memory unit. Now, in the memory we are going to store our information. Now, how to get these things? So, for every memory location we must have to assign a unique address. Like we say, if I want to reach you, at least I must know your address. So, if you are a student and you are staying in a hostel, at least I must know the room number that you are staying, then I have to know in which hostel you are staying. Of course, from outside world I must have to know in which institute you are there. So, like that all those components is going to tell me your location and I can go to your location. Like that, when we are going to take an information from a memory, we must know this particular address. So, we are going to give some address to each and every location, and this address register can keep only the addresses of those memory locations. Secondly, when we are talking about the addresses, several I/O devices will be connected to the computer. So, to identify each and every I/O devices, we must have to assign some addresses. So, those addresses can also be kept in our address register. And we are having one more registers called condition codes. So, we will elaborate it, what does it mean and what information we are going to store in condition code. Now, one of the major decision while going to design a processor is the number of registers. How many general purpose registers we are going to keep? This is a major design decision, because the performance of a processor depends on this particular number. If we are having a fewer registers, then what will happen? There will be lot of memory references. We are going to bring one information from memory, working with that particular information. But if we are having a fewer number of registers in all, we are keeping some information in all the registers, then what will happen? When we are going to bring another information to the processor, we cannot keep in any of the register because all are occupied. Then we have to transfer some of the information from register to the memory to make a vacant space, and in that particular vacant space we can keep this particular new information. So, if we are having a very less number of registers, then what will happen? That memory reference will be more. That means, lot of information has to be taken from memory and intermediately we have to store into the memory. But again, it does not mean that if we are going to increase the register, that is going to put more number of register, again it is not going to reduce the memory references drastically. It will reduce the memory references up to a certain extent. So, it is not like that we are going to work with a very less number of register or very big number of register. In typical way, it is observed that in most of the processor, we are having a register somewhere between 8 to 32. 32 is also in some higher side. So, it is somewhere near to 8 only, or in general I can say that register number of register varies between 8 to 32. Now, when we are talking about the registers, when we are going to talk about this storage element, temporary storage element inside the processor, we must have to store some information, and those information should be stored properly. So, for that we have to see what will be the size of those particular registers. If we are talking about the address register, then at least it should able to store the full address of the memory location or full address of the I/O devices. So, registers address register has to be long enough or large enough to keep the complete information of a memory location or a device. And what will be the size of a data register? It should be long enough to large enough to hold a complete word. So, if we are going to talk about a processor, say we are going to see that it is a 16-bit processor, that means we can work with 16-bit at a time. So, that means the size of the register should be at least 16-bit. When we talk about say 32-bit processor, then we are going to work with a 32-bit data. So, that size of the register should be your 32 bits. Also, it is possible to combine two data registers together to work with more information. So, like that in C programming, if you are accustomed with the C languages, you will find that sometimes you are going to use the double integer. So, integer is a data type, we can have a double integer. So, in case of double integer, we are going to increase our range. So, in some cases depending on the processor, it may happen that sometimes we have to combine two registers together to keep a double integer inside the processor. So, this provision is also you have to provide while designing the processor. So, these are the general purpose register where we are going to store information, data and addresses, and these are feasible to the programmers. So, while we are going to write a program, we may use those particular registers to store our information. But there are some other registers or storage elements inside the processor which are known as your control register or status register. These registers are not feasible to the programmer. Directly we cannot use those particular registers, but for the better operation of the computer or processor, we have to have those particular registers. So, programmer cannot use those registers, but to control our operation while designing we are going to use those particular registers. So, some of those registers is one is your program counter, second one is your instruction register, third one is your memory address register, fourth one is your memory buffer register. Just I am citing 4 registers over here, and these are bare essential register inside the processor to control the operation inside the processor. So, in subsequent lectures we are going to discuss in details about the use of those particular registers. Just here I am introducing that these are the 4 status registers or control register we have inside our processor. There is another one register called condition code register. This is an registers, but here we are going to work with individual bit. So, say that if we are working with an 8-bit processor, then what will happen? The size of the registers are 8-bit. So, we can consider an 8-bit register where we can store 8 different information. Okay. So, in case of your condition code registers, we can work with individual bit. Okay. Either we can set or reset those particular individual bits, or we can use those particular individual bit. So, this is one of the issues. And now, what we can store or what we are going to store over here. So, this bit will be set or reset. Already I have mentioned that set means we are storing information 1 and reset means we are resetting it to 0. So, these are basically made of flip flop. So, flip flop can be set or reset, and when we are going to set and reset, it depends on some operation inside the processor. So, generally it cannot be set by the programmer, but some of the bits we may have which can be set by the programmer. In general, we can say that it is not set by the programmer, but those bits will be set by the operation of a processor. We are performing some operation, and on depending on the result of those operation, we are going to either set or reset those particular bits. And when we are going to use those particular condition bits to make some decision. So, when we are going to design some conditional instruction, say in high level language generally you write something like, no, if a equal to 0, then do something else, do some other thing. So, now here we are comparing it. So, depending on this comparison, if it is 0, then we are going to perform this code segment, and if it is false, then we are going to perform the other code segment. To design such type of instruction in programming languages, conditional instruction, we must have some instruction inside the processor. In the instruction set of the processor, we have to provide some conditional instruction. So, while going to design those particular conditional instruction, then we are going to use those particular condition code bits. So, one of the code bits I can give here like that sign bit. So, when we discuss about the representation of integers or representation of your real number, we have seen that we can work with positive number and negative numbers. So, for that we are having a sign bit. So, when we perform an operation say like that a plus b, then depending on the result that sign bit will be positive or negative. So, depending on that, say if I am going to have a sign bit over here, that sign bit will be set or reset depending on the result of my ALU operation. So, if it is a positive number, if the result is positive, then we say that 0 will be stored. So, 0 is going to indicate the positive, and if the result is negative, then we are going to store 1. So, it is going to indicate that the result coming out from the ALU is a negative one. So, this is one of the condition code. Like that, another condition code I can say carry flag. Already I have said that we are having a carry out of an adder circuit. Similarly, we can have overflow bit condition code, because we have seen that the range of numbers is restricted by the design of the processor. We cannot go from minus infinity to plus infinity. So, depending on the ALU result, sometimes it is go beyond those particular range, and in that case we are going to say it is an overflow. How we are going to identify the overflow? So, in that particular case, what we are going to do? We are going to keep this information in one of the condition flag, and to take the decision, we are going to see what is stored in this particular position. So, this is a condition codes, and condition codes are basically known as your flags also, flag bits. So, you can say these are flag bits or condition bits, and already I said that we are having a condition code registers, and whatever value we have in this particular condition code register, this is also known as my program status word, PSW, program status word. Basically, it says that what is the status of my program at that particular point, because some of the at some point of time my result may be your negative, or at some other point whatever value I am getting, it may be an overflow condition. Sometimes my result may be 0. So, like that we can have flag bits inside this particular PSW, program status word or condition code, one bit for your sign bit, one bit to indicate the 0 bit whether the result of the processor is 0 or not, one bit to indicate whether carry out is generated or not, another bit may be saying about what is an overflow occurs in the computation or not. So, these are the bits which will be set or reset depending on my result of the ALU. Along with that, we may have some other bits also condition code which may be set by your programmer while writing his program. So, one of these things is maybe it is talking about the interrupt, enable and disable. So, just to give an idea, I am just giving you one example. The interrupt means like that we can interrupt or we can disturb the working of the processor. Say processor is executing a particular program, but at some point of time I want to give some input from the keyboard, or maybe I want to control some other devices to the computer. In that particular case, that program will be interrupted and the processor service will be given to that interrupted request. So, that interrupt, whether we are always going to allow it or for some cases we are going to disallow it. So, again to have these things we may have one bit which is going to indicate about that whether interrupt is allowed or it is disabled. So, basically sometimes it may happen that when we are performing some high priority job, we feel that or we expect that no one should disturb me at that particular point. So, in that particular case what will happen, we can disable this particular interrupt. After completion of the task we can enable it. So, we are having some more flag bits which can be set or reset by the programmer. So, these are the registers. So, what registers we are getting? Basically storage element. One, we are having the general purpose registers. Secondly, we may have some dedicated register to store only data and store only address. we are having some special purpose register. Here I have mentioned 4 registers called program counter, instruction register, memory address register and memory buffer register. And along with that we are having a special register called condition code register, where we are going to store the status of the processor. So, these are the some storage unit or element we have inside the processor, and these are known as our register. And what is the another component inside the processor? This is the ALU, arithmetic and logic unit. So, ALU is going to perform the basic operation inside the processor. So, it is nothing but a combination of processing element. So, in a nutshell, simply we can say that it is like that inside that ALU, we are not going to look into it, we will just see it is a black box. So, what we are having? We are going to give input from the registers, it will perform the operation depending on our request. So, control unit, some signals will come from the control unit, it will identify which operation we are going to perform. After performing the operation, it is going to give us the result, whatever result we are getting, we can again store it into the registers. And so, I have mentioned that depending on the result, it is going to send some of the flag bits like that. After performing some operation, if overflow occurs, then what will happen? That overflow bit will be set by those particular signals. So, some flag signals will also come out from the ALU, and according to the status of those particular signal, we are going to set or reset those particular flag bits. So, in a higher level, we can see that ALU in this particular way, we are having input, we are having output, we are having some control signal as input and some of the data or bits, flag bits as an output. So, this is another component inside the processor, which is ALU, and this is the basic processing element inside the processor. Now, another component is your control unit. So, what is the function unit, or sorry, what is the function of those particular control unit? So, what will happen inside a processor? We are having several operations, and we say this is the instruction of the particular processor, and we are having an instruction set. So, for every instruction we are going to provide an unique code, like that here we are talking about that I can perform an add operation. So, for that particular add operation we are going to give a unique code to it, because we are going to work with the numbers, or you can work with the binary digit only, zeros and ones. So, one unique code will be given. Say I can say that this is 001 is going to give it for add operation. So, similarly, if I am going to perform the subtract operation, then I am going to give another unique code it. So, if I want to move the information from say register to ALU, then what will happen? We must have an instruction, we must have an operation for that, and this operation is also going to get an unique code. So, I am going to say that 001 is the code for that, if we are going to work with 4 bits. So, this is the way we can say that we are going to give an unique code to each and every operation. And when we get this particular unique code, we know what operation we need to perform. That control unit is going to generate the appropriate signal to carry out those particular operations or carry out those particular tasks. So, when we talk about that add instruction going to perform the add operation, it may have several sub steps. So, in every sub step, that control unit is going to generate the appropriate signal, and that will go to the appropriate component inside the processor to enable that particular component. So, this is the function of our control unit. So, now in a nutshell, now we can say that what are the components that we are having inside the processor. So, CPU mainly consists of register for internal storage, it is having a control unit, and it has an arithmetic and logic unit. So, these are the 3 major components that we have inside a processor, and these components are connected through our interconnection network. Now, to work with this particular processor, what will happen? We have to bring the information inside that processor. So, for that somehow we need to bring this particular information, and somehow we have to give the output to the users. So, for that we need this particular input output mechanism. So, as a simple example, I can say that keyboard is my input device. So, through keyboard I can give the input to the processor, and monitor is an output device. Through monitor I am going to get it. Secondly, and another way, we need one more component which is known as your temporary storage for code and result and it is known as my main memory, because the computer works on von Neumann stored program principle. So, we have to keep those information in the main memory. So, along with the processor, we have input and output, and we have main memory or storage unit. So, in this particular way, now we can see the components of my computer. It is a top level view. So, this is the processor, CPU. So, CPU, we are having some internal registers called, already I have talked about, say PC is nothing but program counter, II is nothing but instruction register, MAR is your memory address register, MBR is your memory buffer register. Along with that, we are having two more additional register. We are talking about IOAR, that means IO address register, and IOBR, IO buffer register. So, these are the special purpose register. Along with that, we are having some general purpose register also, and this is the execution unit, basically ALU. So, it can perform work, then we have to bring the information from main memory. So, this memory will be connected to this particular processor. We call this is the system bus. So, through bus we are going to connect this particular memory. Already I have talked about bus is nothing but a connecting wire. Inside the processor also we are having an internal bus. Through that internal bus we are going to transfer information from one component to the other component. In case of your computer, through this system bus we are going to transfer information from main memory to the processor. Again, that IO module, input output module will be connected to this particular processor through this particular system bus, and all input output device will be connected to this particular IO module. So, we are going to discuss these things in details in subsequent modules. So, this is the top view of our computer, and these are the components we are having: processor, main memory, and IO module. Now, what is a program concept? Now, why we say talk about a program? What is a computer program? It is nothing but collection of instruction, and we are going to perform those particular instructions. So, here we are talking about programming concept and why this programming concept is coming into picture. It says that, just I have written it like that, hardware system are inflexible, but computer is also a hardware device. Okay. We build the computer with a hardware which is nothing but your electronics component. But in general, you can say that hardware systems are inflexible. Here I can give you a simple example. If you talk about the television, okay, TV is also an electronic device. So, we are having several components, electronics components, it is the television. But television is performing one particular task only. It receives the signals, and according to the signal received, it is going to display it in the monitor. But along with that, what will happen? We are having some provision to change the channel, change the brightness or contrast, all those things. But it is only going to perform that particular task only, receive the signals and display into the monitor. And you can see it, but you can, there is some provision to change the channels, program it with the help of different channel and like that, but we cannot do any other work. But if you are going to look for a general purpose devices, then what will happen? We must have a provision to configure it according to our requirement. That means, we can program it according to our requirement. So, in that particular case, we are going to say it is a general purpose hardware. So, computer can be treated as a general purpose hardware, because we are having the programming facility, and with the help of program we can carry out our tasks. So, that is why it says that in general hardware systems are inflexible. So, if we are going to design an hardware circuit for to perform a specific task, in that case we are going to say this is your ASIC, application specific integrated circuit. So, like that we are having an ICs for our TV, television. So, this is basically ASIC, the application specific integrated circuit. But when you go for general purpose or when you go for computer, then what will happen? In that particular case, we are having an IC, but this IC we say this is the CPU or processor. So, this processor can be programmed according to our requirement. So, from that concept of programming is coming into picture. So, when we are talking about the programming concept, one of the issues, or all of you know that we are having an operating system. So, when you are going to switch on your computer, generally we say that we are booting up our computer, and when we say that we are booting our computer, we are booting it with the help of some operating system. We are having several operating system, and you know that basic one is your Windows, but you know about Unix, you know about your Linux, like that. Now, what is an operating system? So, for this programming concept and for this particular your work, when we are going to discuss about the computer organization and architecture, here we can view this operating system as an extended machine. Why we are talking about that extended machine? Because every computer or every processor is having a specific instruction set. So, it depends on the power of the processor, and we can say we are having n number of instructions. So, whatever we are going to do, we are going to do everything with the help of those n instruction only. So, we have to write a program to perform any operation in that particular processor with the help of those particular n instruction only. Now, one of the issue I can say that now whatever we have inside the memory, so I am storing some information in the memory, I want to display those information to the monitor so that user can see it. So, now when I am going to perform this particular task, taking the information from memory and displaying it into the monitor, I have to write a program. And when I am going to write a program, then what will happen? I have to know this particular instruction set, and with the help of those instruction set, I am going to write a program to display the information from memory to the monitor. Now, what happens? You just see, as a common users, you have to write this particular program every time, and you have to know that complete instruction set. So, for that what will happen? Such type of routines we are going to write in one go, and we keep everything in one place, and we say that this is the component of my operating system. Okay. So, when we boot, then all those instructions will be in place, so that I can use it. So, now that is why I am saying we are going to view this operating system as an extended machine. So, whatever n instruction we are having, with the help of those instructions we can create another say m number of instruction to do different operations. So, total instruction I can say that m plus m. These m instruction are basically some software written with the help of those n instruction, and they are integrated together and kept in a part of this particular operating system. So, this is why we are saying that operating system can be treated as an extended machine, and what we are having basically in operating system, it is a collection of some programs, and these programs are made up with the instruction of that particular processor. So, these are the programs concept that we have in computer. Now, what is a program? Now, in a nutshell, you can say that it is a sequence of steps. So, we are having sequence of steps, we have to write in proper sequence, and when computer is going to execute this program, then it is going to execute those particular step or instruction one by one. And for each step, an arithmetic of logic operation is done, because we are having the ALU, we are going to perform some operation with the help of this processing element. And for each operation, a different set of control signal is needed at different time stamp, because already I have said that when I am going to perform an or execute an instruction, we have to perform some tasks, and to perform some tasks means we have to transfer information from one point to the other point, we have to perform some operation. So, control units need to generate those particular signals at appropriate time. Now, when we talk about an instruction, in one go we cannot have the effect of that particular instruction. It is going to execute this particular instruction, and at some point of time I have mentioned that instruction cycle can have two cycles, one is fetch and second one is execute. So, we can say that two defined tasks we are performing to complete that particular instruction. Now, in every cycle we may have again several subtasks, and combining all those particular subtasks we can say that we are completing the fetch cycle. Similarly, in execution cycle we are going to perform different subtasks. After completing those particular subtasks, we are going to say that execution cycle is over. So, each cycle like fetch cycle and execute cycle has number of steps, and all those steps are doing very little work, and we are saying that these all little works are basically some micro operation. So, after combining all those micro operations, we are going to effect of the operation. So, in this way we can see. Now, here we are going to see how we are going to look for those particular micro operations. So, this is the instruction cycle. In nutshell, I can say that it is having two cycles. One is your fetch, second one is execute. So, what fetch means? We are fetching the information, we are fetching the instruction, then processor will be knowing what we need to do, and accordingly processor is going to carry out the job, and we said this is the execution fetch. So, basically where from we are getting it? Computer works on von Neumann stored program principle. That means we are having this particular processor, and I am having this particular main memory, and it is connected through this particular system bus. So, in main memory we are having this particular program, we are storing it, and so somewhere we are having this particular data. So, when I am going to execute an instruction, that instruction in this particular memory location, I have to bring it to the processor. So, this is called fetch. I am fetching the information, and after that once I fetch it, now I know what to do. Accordingly, I am going to execute it, and after completion of this instruction, then I have to go for the next instruction, because program is a collection of instruction, and we have to execute those instructions in sequence. So, that is why this cycle will repeat. So, now this is the fetch and this is execute. Another one we are having indirect cycle. Already I have mentioned that sometimes when I am fetching the instruction, before execution I have to need the data. So, for getting the data I can go through this particular indirect cycle. So, in this particular case I just say I am fetching the instruction to the processor. After getting the information that I need to perform some operation, and processor now see that we have to act on some data, but these data are not available inside this particular processor. Then it will go to the indirect cycle, and from through this indirect cycle, since I know that my data is somewhere in this particular memory location, it is going to bring this particular data inside the processor. So, this is basically indirect cycle. So, in indirect cycle we are going to bring the information inside the processor. Now, once my instruction is available, once data are available inside the processor, then processor can carry out those particular operation. So, this is indirect cycle. Now, basically what we are going to do in a fetch cycle. So, it is a fetching an information from memory to the processor. Now, what we must know when we are going to fetch an instruction, at least we have to know the memory location where we have the instruction. Now, where I am going to get this particular information. So, already I have mentioned that we are having a special purpose register called program counter, PC, program counter. So, in that particular case what will happen, I am having a register called program counter, and program counter will have the address of this particular memory location. Just say that it is a number address, you just think as a number, say this is the 0th address, first location, second location, like that we are having total n minus 1 location. So, 0 to n minus 1 total n location. So, we know the address is say 50, then program counter will have the value 50 over here. That means, program counter is going to give us the information from where we need to fetch the instruction. So, we are having a register called program counter, and this program counter is going to give us the information where from we have to fetch the instruction. Now, after fetching one instruction, then what will happen? We have to, after completion of this particular instruction, we have to fetch the instruction from next memory location, because it is in the sequence. So, that is why we can say that sometimes we have to increment the PC also. First, it is going to have the address of an instruction, processor fetch this information from memory to the processor, and along with that it will increment the PC, because after completion of this particular instruction, what will happen? We have to go to fetch of the next instruction, and next instruction will be available in the next memory location. So, after fetching the information, generally we update this particular program counter, we just increment it. After that, whenever we are getting this particular instruction, this instruction will be loaded to instruction register. We are saying that we are having a special register called instruction register. So, when we fetch an instruction, after fetching it, we are going to keep it instruction register. One, we have the instruction in the instruction register, then processor will be knowing what operation we need to perform. So, that information will be given to the control unit, and control unit is going to generate the appropriate signal. So, once it is having in that instruction register, so now we are saying that processor interprets instruction and perform required action. So, that means processor interpret the instruction. So, after getting the instruction, we know that we have to perform say addition operation. Then processor is going to perform the required actions. That means control unit is going to generate the correct signal at correct time, so that operation can be performed in correct way. So, this is the first cycle, and now in a symbolic way, now I can say how we are going to do the fetch cycle. Now, already I have talked about PC, that program counter that we are having, and we know IR, instruction register. After fetching it, we are going to put it into the IR. Now, how we are going to do it? Again, we are having two special purpose register. One is known as MAR, memory address register, and second one is your MBR, memory buffer register. So, these two registers are basically the interfacing register of my processor. So, now what I can say, this is my processor, I am having a register called MAR and another register called MBR, memory address register and memory buffer register. Just say that this processor is connected to main memory or maybe to IO devices also. Now, how we are going to interact, how we are going to fetch it? You just see that somehow I have to give the address of the memory location, and whatever data we are having over here, we are going to bring it into the processor. So, these two registers are going to act as an interfacing register. So, if I want to read the information from a particular memory location, then first that address we have to put it into the MAR. After that, this address will go to this particular memory unit through this system bus. Okay. Then we are going to read the information. So, that is why I am saying that first I am going to place the information from PC. What we have in PC? In PC we have the address of the memory location from where we need to fetch the instruction. So, first that information of PC is transferred to MAR. So, now in MAR we are getting the address of the memory location. Now, I will generate the read signal. So, control unit will generate a read signal. What it will say that now we want to read the contents of this particular memory location. And once we are getting this particular information, then reading it, one read is complete, then what will happen? The information will come to your MBR. So, now say first cycle clock we are placing the PC to MAR, then giving a read signal, we are going to read it. Now, in second cycle what we are going to do? We are going to take the information from memory to MBR, and along with that what we are doing? We are incrementing the program counter PC equal to PC plus 1. Okay. Now, once this time cycle 2 is over, then what we are going to do? Now, that information is inside my MAR. Now, what we are fetching now? We are fetching the instruction. That means, we have to execute this particular instruction. So, in the third clock cycle, we are transferring the information from MBR to IR, instruction register. So, now I know the instruction, what instruction we need to execute. Now, accordingly, now control unit is going to behave, control unit is going to act and going to execute this particular instruction. Just see here, that means to fetch itself, we need 3 clock cycle or 3 steps. Now, again see in the second step what we are doing, we are performing 2 operations, memory to MBR and PC plus 1, adding the PC and keeping it, updating the program counter value. Now, why it is possible? Basically, just I want to mention it. This is a processor, CPU, it is an electronic device, this is a memory unit, this is also a semiconductor device. But the speed of the processor is not same with the speed of the memory. Memory is always slower than the processor. So, for that, while I am transferring this particular information, it takes more time. So, since it is taking more time, so during that time inside the processor also I can carry out some work. So, that is why I am doing P c is equal to P c plus 1. Okay. So, this is the way we can do it. Again, this is a read, we are reading it from memory to the processor. Similarly, we can have the write operation also. In write operation, what happens? We are going to write the information from a register to the memory. So, in that particular case, what will happen? First, we will give the address to MAR. That means, we are going to identify the memory location where we are going to write or store the information. Then we will put our data into the MBR, memory buffer register. Then we will give the write signal. Then what will happen? Whatever information we have in our MBR, that will be stored in this particular memory location. So, we are having two operations, one is called read operation and write operation, and while we are interacting or interfacing with external to the processor, mainly that MAR and MBR is going to act as my interfacing register. Now, here what will happen? In this particular case, we are doing some operation parallelly, or sometimes you can say that we are performing this step, then only coming to this step. Why I cannot perform both together? So, there is some resource conflict, that is why everything cannot be done in one clock cycle, we have to perform in different steps. So, for that there we have to follow some rules. What are the signals that can be grouped together, and we say this is a clock grouping. First thing is that we have to maintain the proper sequence. So, what will happen? PC to MAR always precede memory to MBR. So, basically you just said that after knowing the address only I can get the information from memory to MBR. So, this operation cannot be performed before the first operation. So, this is the proper sequence. So, first I have to press the program counter to MAR, then only I will be knowing. So, PC to MAR must precede the memory to MBR. Again, some conflict must be avoided. Why I am saying that everything cannot be done at one go? Because there may some conflict may occur. So, we should not must or we should not read and write the same register at the same time, because if we are reading from some memory location or reading from a register at the same time, we should not write the same some information to the register, because it will change the contents of the register. So, read and write should be in two different clock cycle. Again, memory to MBR and MBR to IR cannot be done in the same cycle, because here we are storing some information, it will take some time. After getting the proper result only I can transfer it to IR. So, they cannot be done in the same time. So, like that we have to see what are the things, what are the signals can be generated at the same time, so what are the subtasks can be done in the same time, they will be done in one clock cycle. If there is some resource conflict, then surely we have to go into two different steps. So, that is why by looking into all those particular scenario, we are saying that fetch cycle is going to take three different clock steps. It cannot be done in one clock step or two clock step. Now, what is an execution cycle? Now, say once we are getting the information in IR, in instruction register, now I am having that instruction. Some instruction we have fetched and we are having it. Now, according to this instruction, what will happen? We have to perform our operation. So, this information will basically go as an input to your control unit. So, we are having a control unit inside the processor. Now, this control unit is going to generate those particular different control signal, and those control signal is going to control different components, or basically going to perform different tasks. Like that, say first in the fetch cycle itself we are talking about, say PC is transferred to MAR. So, in that particular case control unit is going to generate some signal, it will indicate that whatever value we have in the PC, just read the contents of the PC and it will generate another signal. It will say that now whatever information we have read from the PC, now write it into the MAR or store it into the MAR. So, these are the control signal will come out from the control unit. So, like that, after getting the instruction, we are going to get giving it to the control unit. Now, control unit will generate a control signal. So, here what are the operation basically we are going to do? One is your processor to memory, that means data transfer between processor and main memory. So, this is basically transferring the information from processor to memory or memory to processor. This is one kind of operation that we can have. Another class of operation we may have processor I/O, that means information will be transferred from processor register to some output device, or maybe from some input device we are going to take the information to the processor register. So, these are another class of instructions. So, depending on that we have to perform our task. So, in execution cycle basically we are going to perform those operations. Third category we are talking about the data processing. Basically say if I am having my data, then what will happen if it is an add operation, now we have to perform the add operation. So, we are going to use the ALU, that adder of the ALU to perform the operation. So, control unit is going to generate those particular appropriate signal to trigger those particular device. And another one, it is control or say sequence control. Basically in some of the cases we are having jump instruction or jump on condition. So, such type of operation we have to do, for that we need appropriate instruction. Like that I have already mentioned that if you are going to write a program like that A is greater than B, then perform this instruction, else perform the other. So, if it is false, then what will happen? We are not going to execute this part of code, but somehow we have to come to this particular instruction. Okay. So, for that we need those particular control instruction, or some instruction may be combination of some of those particular operations. So, we have to in execution cycle or execute cycle we are going to perform those particular tasks. So, indirect cycle I have already mentioned. So, if we need data for my instruction, we will go to the indirect cycle and we are going to fetch the data and keep it in some register inside the processor, which are nothing but temporary storage inside the processor, and accordingly we are going to use those things. Now, this is the component that we have discussed here today. So, processor is the main component, central processing unit. It is having a processing element, and this processor is connected to main memory or I/O devices through system bus and works on Von-Neumann stored program principle. And now we have seen what are the basic components that we have inside this particular processor. Till now we have not discussed anything about the main memory. We will see the construction of the main memory while we are going to discuss about the memory module. Secondly, we are going to see the complete design aspect of this particular processor when we are going to discuss about the central processing unit or the processor design. But here just in top level we have seen how we are going to perform an operation and what are the tasks that we are going to perform. So, with this we are giving and having now a brief idea about what we have inside the processor, why memory need to be connected to the processor, because it works on Von-Neumann stored program principle, and how a program is executes. Basically, it is having basically two part. I can say that fetching of instruction and execution of instruction. Fetching is basically done from the fetching information from memory. So, here in this case you just see that we are having 0 to n minus 1 total n memory location. So, in this particular memory location we are having those instructions. So, we can say this is my program, and while I am going to execute this program, it needs some data. So, this is the data that we have here in the main memory. So, processor need to take those things. Okay. So, this is the basic ideas about the components of a computer, and also we have mentioned about the components that we have inside the processor, and see what is a program and how we are going to execute a program. Now, just look for some test item that whatever we have discussed today. So, first question I have given here like that, what are the different components of a processor? I think by now you know all those things, but you do not know about the details how we are going to design it, but in top level you know it. So, we have identified some objective for this particular unit, and this question is basically related to objective 1. So, if you fulfill the objective 1, then you will be able to answer this particular question. So, basic three components we are having. ALU registers and control unit, and they are connected to a interconnection network. Why registers are required inside the processor? Again, it is going to meet the objective 1 and objective 2. So, this is basically temporary storage. We have to have our information inside the processor. Computer works on von Neumann stored program principle. So, informations are in your main memory. While we bring this information from main memory to the processor, we need some storage element. We have to keep those information in some place. So, these are nothing but the registers. What is the use of program counter and instruction registers? I think already I have mentioned about it, what we are going to keep in program counter and what we used to keep in our instruction register. Why MAR and MBR is needed? Again, it is going to fulfill the objective 1 and 2. I think in my lecture I have mentioned that these are the interfacing register for processor. So, we have to give the address of a memory location, we will give it in the MAR, and whatever data we are going to use, either I am going to take it from memory or we are going to write it in the memory, it will pass through this particular MBR. So, explain the steps required in fetch cycle. So, instruction execution is having 2 cycle, fetch and execute. Fetching is nothing but taking the information from main memory to processor. So, we have to perform a specific task for complete this particular fetching of the instruction, and this is same for all the instruction, and already we have discussed how we are going to do it. Now, question 6, why indirect cycle is needed in some instruction? This is objective 3, because if instruction needs the data, but data is not available inside the processor, then we have to take it from memory. So, with this I wind up this particular lectures. Hope you have enjoyed the lecture. Thank you very much.